So in this video, I'm going to show you how to build a model of the diamond structure. Now, diamond is pure carbon. It's nothing but carbon atoms. It's sp3 hybridized, meaning that you have tetrahedral geometry with each carbon connected to 4 of the other type. First thing I'm going to do is build a ring. I'm going to build a 6-membered ring. I'm going to connect the 6 of these. I'm going to connect the 6 of these to form a 6-membered ring. Alright? So we may have to bend this around a little bit to get it into the proper conformation, which of course begs the question, what is the proper conformation? What you want to see is this alternating pattern of up-down atoms. So for example, that one's pointed up, that one's pointed down, this one's pointed up, that one's pointed down, this one's pointed up, that one's pointed down. So for those of you who have had organic, you might recognize that as a cyclohexane type ring, except that cyclohexane is obviously a hydrocarbon, and this is going to be pure carbon. So anyway, we're going to take the 3 that rise up, that come up, or pointed up, and we're going to add to this. Okay. So we have this. Okay. And then we're going to tie those together with another atom, okay, to complete this sort of almost a cage-like structure here, okay, which looks like this. Now, there's something I want to point out about this real quick. And if I add 4 bonds rather to this, just to illustrate the point, okay, that this structure is basically a tetrahedron. Okay, if we take these 4 bonds, that I'm going to put my fingers on them here, we take these 4 bonds, that's just a big tetrahedron. Okay, that's just a big tetrahedron. So it's constructed from tetrahedra, and overall it's going to have tetrahedral geometry no matter how big we build it. So let's keep building this out. So what we're going to do is we're going to build on a couple of more 6-membered rings. So we'll start here. So we have 2. We already have 2. We're going to fuse 2 of the rings together starting here. So we're only going to have to add 4 more atoms. Okay, so we only have to add 4 more atoms. So that's 2, 3, and 4. Okay, it's going to look like this. Now we're going to have to be sure we maintain that up-down pattern. That has to be rigorously maintained. So obviously this one is up. That means this one has to point down. The next one will point up. This will be down, and this one will be up. Right? So we're going to have 3 that come up, except that we're sharing rings, and we already have 1. So we're only going to add 2 more atoms coming up. Like this. Okay? And then what we're going to do is we're going to tie those 3 together. The 3 that come up, this one, and this one. Here, here, and here. We're going to tie those 3 together. Okay? So now we have 2 of these structures fused together. Let's add a 3rd. So now we're going to add here and fuse to these 2 rings. So we already have 3 atoms. So now we only need to add 3 more to complete that six-membered ring. So again, we have to maintain the up-down pattern. This one is up. Obviously, this one is up. That one we have to be down. This one will be up. This one down, and obviously that one is up. So we already have two up atoms in this ring, here and here. We're only going to have to add a third one. We only have to add one more to make three. So again, we're going to tie all these together. Okay, so that you get something that looks like this. Okay, looks like this. Now, I want you to note that this has a couple things. First of all, this has three-sided symmetry. That's the reason I added two more rings and not just one more, right? This forms a sort of triangle here that I could rotate this 120 degrees and you would not be able to tell the difference. Okay, 120 degrees, you would not be able to tell the difference. It's always a good idea to try to maintain the symmetry when you build these things. It's possible to go off on a tangent and build a structure that's technically not incorrect, but doesn't really show the structure well. Anyway, so second thing I want you to note is the six-membered rings that we have down here. The three six-membered rings are forming sort of a layer. In fact, we could just keep going out and building out these puckered six-membered rings and build it into a layer. Now you're seeing the start. We just have a small piece of it, but you're seeing the start of a similar layer here. That are the three up atoms that we added. We formed another six-membered ring. So this would be the start of another layer of six-membered rings, except for the fact that this six-membered ring is offset from these. It doesn't lie directly on top of this one, and it doesn't lie directly on top of this one. So it would be the formation of the start of a second layer of six-membered rings. So now let's keep going with our structure. Tighten this up a little bit. Okay, and so now let's keep going. So now we're going to come up. We have up atoms here, here, and here. So let's add to those, and we're going to come up, and one there, and one there, right? Okay, so we've gone up, up, and up. And then, as we did with all the other cases, we're going to tie those together. Okay. And here we have it. Okay. So what we've done is we made an even bigger tetrahedron. This structure, as big as we made it here, still has the original tetrahedral geometry that we started with. I could turn it this way and it would look the same. I could turn it this way. I can turn it this way. You can't tell one corner from the other. Now, there's something I want you to know too. We'd have to build it a lot bigger for you to see this. But this last atom that we added this would be the start of another set of six-membered rings. If we built this out and we came around here, we'd have another ring, but we would have three separate and distinct layers of six-membered rings. We'd have the first layer, and we'd have a second layer here. We'd have a third up here, and then we would begin to repeat the fourth layer again. So if you remember right, a cubic structure is constructed from A, B, C hexagonal layers. This is related to that. You have layer A, you'd have layer B, you'd have layer C, and then we would start it all over again. So we would have to build this model out bigger for you to be able to see that. And this is as far as we're going to go for this one.